All right, so today we're going to talk about some basic OOP concepts here. I want to start with interfaces. I think interfaces and understanding interfaces is easily one of the most misunderstood pieces of object-oriented programming. When we interview candidates, I commonly find that people A, have never used an interface, B, don't know when to use them, or C, have never even heard of an interface. Um, I interviewed a Java developer 2 years ago, and when I asked him about interfaces, he thought I was referring to a UI, a user interface, had no recollection of the word being used in backend programming. That's fairly scary, but I can remember myself 17 years ago getting out of college. I can remember having little to no real education on how interfaces work, when to use them, how they can aid you, and what their importance is in programming. That being said, before I show you some programming, before we actually recreate this program here, what I'd like to do is I'd like to talk for 60 seconds about the purpose of an interface, and that is when you are putting together an application, there are going to be times where, whether it's just you or a team of 50, you may have classes that all have to accomplish the same tasks, although they may accomplish the same tasks differently. So let me give you a real world scenario, and that is going to be car. So every textbook in the world uses car. I think it's a great example as well. So you have your main class car, and we know that every single car is going to have to turn on, it's going to have to turn off, it's going to have to move forward, etc. How each car does this is extremely different from one to the next. They have different engine types, they have different mechanisms, computers, different ages. Something from the 50s operates much different than something now. But all I really want to know is I want to be sure that every single car, every car that I implement has a turn on, turn off, etc. And in order to make every class do that, I could program every class to do that without an interface, but there's nothing forcing me to do it. So the interface is a great way, especially if you're a software architecture specialist. And trust me, if you do architecture for a living and you've never used an interface, you may be in the wrong profession. But that being said, an interface is a great way to force those programming on your team with you or yourself to implement all of the requirements to have a basic car. Or in our case, we're going to use video games because I think video games are a lot more fun than cars. So what I have here is an example application that I created, and what I'm going to do here, I'm going to leave it open because I'd like to grab code from it as we do this, but I don't want to recreate it all from scratch. So I'm in NetBeans, by the way. I like NetBeans for these tutorials. It's a simple interface. It's free. It's easy to use, and it's got a wide popularity. I'm going to do a basic Java application here, and we're going to say working with interfaces com.etho.working with interfaces. There we go. And we'll talk about naming conventions in a different video. Don't be too alarmed by my conventions there. And you'll notice the first thing it creates for me is this main class. Once again, guys, we're in Java. This is a console application. Therefore, this particular application is going to come with essentially the bare bones to run it via console. Or in my case, I'm just going to run it in the NetBeans IDE. So first thing I want to do is I want to create my interface for these video games. So we're going to do new package, and I'm going to just call it interfaces because this is a tiny application. And we have one right here that we're going to copy. Beautiful. Actually, I'm just going to copy the class this way. There we go. You'll see it took on the name of the package that we put it in by copying it there, and you'll see we have these basic methods. So here's the part where I think most people get confused. An interface doesn't actually contain code that does anything. It doesn't. All an interface does is it defines what methods or properties a class must have in order to be a video game. So in order for a video game to exist, it must start, stop, pause, go to menu, and save your progress. If it doesn't do that, it cannot operate as a video game. And if it cannot operate as a video game, it's not going to work for our end users. So these are some really basic, simple requirements. But you see, there's no code. We're just defining that it must be public. In our case, we're not passing back anything from the method. And then this is the name of the method. In your implementing class, it must match this setup here. So let's go into, so we have our interfaces. Let's go to, let's do, oh, look at that, someone's birthday. All right, and let me just turn off notifications here. There we go. And we're going to name a video game here, and we're going to name this Sonic. And then we're also going to create another one, Mario Brothers. Alright, we'll start with Sonic. So you'll see Sonic as a class. Those of you who have seen a class before, this is identical to what you're used to seeing. There's nothing here that's going to be odd or out of the normal for you. That being said, there's nothing here that forces me to implement what was in the interface video game. So we have to do implements video game, and immediately you're going to see a red mark. First of all, it doesn't know where video game lives, so we have to tell it. We have to do import and then the location of that class. But also, you're going to see it says implement all abstract methods. It's giving me a red line because we said that, hey, we're a video game. We implement the video game interface, but we don't have any of those basic methods that are required for doing the work we said we're capable of doing. So if you're lazy like me, you can just do implement all abstract methods, and it's going to automatically fill in all that code for you from the interface. You can go in here one by one and start to fill in your logic. In my case, I'm going to steal the logic from the Sonic class because it's basically identical to what I want to do here, and I want to talk through it. So each of these methods, I've just implemented a little bit of code. Here's just a for loop to print out 1 through 5 to simulate a boot up lag or process. And then we also have, we're printing out start finished. We're printing out the same thing but stopped, paused, display, progress. So these are really basic methods here. Notice that they use the word override. For every method that overrides a class in the interface, you need to have this annotation. And then you'll also notice that this is public void start. This matches, this is what you call your signature right there, your method signature. Notice it matches identical to this. Alright, so you can see we have all the methods we need here. Essentially we just want to prompt the user, and then we want to prove that the method ran for the sake of our video here. So and for those of you wondering, the /n tells the console to add an extra line break. But since we're using print ln for print line, we already have a line break in there. So I'm just going to remove the duplicate break here so we have more space but not too much. And if you look at our Mario Brothers class, very similar setup here. We're in a position where these two can now, they can perform these functions differently, right? So I could say, Let's add a method here. So we'll say private string name. And in fact, this is actually something we probably ought to add to our interface. So let's do public string name. This is, notice there's no method here, right? So we'll do I'd like to do get name actually, because I'd like it to be a getter. And we don't need a setter, mainly because we're going to set this inside the class itself, so it's not going to get set. Yeah, I'll show you. So in our constructor here, what we'll do, we'll say private string name equals Sonic. Now this is going to set itself at instantiation time. You could, if you wanted to, you could make it blank and you could set it in your constructor. You know, we don't need to get too fancy here, but we do need our public string get name getter here. So we're going to return this dot name. Beautiful. So the reason why I like to do it this way there we go. I like to do it this way. I think it's more versatile. If you look at a lot of different large applications, you'll notice that that's essentially what they do as well. So you don't want to pass a name into the class when you instantiate it, mainly because you want the class to know who it is. So this is a great way of having a defined method that passes back the name. You know, get name is going to exist on everything that implements video game, and we just set it here in the class, so at all times we know what it is. And we need to change this to Mario Brothers. Alright, so we can say, instead we'll say has finished loading. And we're going to prepend it with this dot get name. Oops. There we go. We'll do the same thing for stop. There we go. Alright, and let's do one more here. Alright, so what I want to do is I want to copy these methods over to Sonic, because I like them. I think they make sense for both video games. I missed start. There we go. So now we have these methods here that once the video game has started, we can now implement our own custom functionality that only Sonic does here. So system.out.println something custom, right? So this is just something that Sonic does that Mario Bros. Won't do. So you can see we still have all the same methods as Mario Brothers. It's just that they're doing different things. So this is the first step. So we have one interface and we have two classes that implement from those interfaces. And you can see they are doing things inside of each class, and those can operate independently even though they're named the same. In our video game class, we've defined some properties here, methods rather, and let's go to our main class here. This is where I want to focus next, and let's see here. I want to copy these two items here. These I already wrote because I didn't want to write these on the fly. And you'll see in NetBeans it will automatically look at the classes I'm going to be using, objects I'm going to be using here, and it's going to auto import for me. Another reason I like to use an IDE. Now we do have to make a spelling correction here because it's not called Mario Brother anymore, and and then also this class itself is going to be different. So we'll need to import video game as well and change this to the name of this class since it's not OOP anymore. And let me talk through the methods I created here. So I created a method called ask user for game. So the first thing I want to do when this application loads up is find out what game do they even want to play. So the first thing I do is I check to see if this method has a message passed into it. If it does, I'd like to override this default message here with whatever message gets passed in. The next thing after I display the message is I actually want to now ask the user to give me input. So right here you can see I'm asking the user to give me input, and then I'm assigning that input to a string named s, and then I have just a real simple if-else statement here to determine if they press 1, we're going to start up Mario Brothers. If they press 2, we're going to start up Sonic. And you'll see we're returning, but the return type here is still video game. Since these two classes, Mario Brothers and Sonic, both implement video game, this class can return video game. We don't have to know, this method does not have to know which end class we wind up turning into an object, since they both implement from the same interface. At the end here, you'll see though, if they don't select 1 or 2, which is very likely, people make mistakes all the time, they could type in a 3, which isn't a valid selection. In that case, we want to run this whole method again, except we want to change the message up a little bit. We'll say please choose either 1 or 2, just be a little bit more explicit with our instructions. And once it calls this method again, you'll see this time around message won't be empty, and we'll actually print out that message we wrote down here. This method right here is basically going to loop until they press 1 or 2. If they don't press 1 or 2, it never moves on from this step. If they press 1 or 2, we then like for them to be able to interact with the game, pause it, start it, stop it, etc. And that's what this method does. This method will once again prompt the user to do something, and essentially we then look at that output and we call the game that got loaded, we call the pause, start, stop, go, save, etc. And then if they do nothing, we essentially reiterate the response here. So there is one other thing we have to do here. Where is it at? Give me 1 second. Oh, here we go, up in our main here. So there we go. If we go back to our main method here, so this is the method that Java will start automatically when the console loads. As soon as the application starts, it calls, it will call main. That's how Java works. And in our case, for the sake of a simple example here, that's fine. Not that people write to main console applications anymore. So if you look at our main method now we say we want to know what video game we're going to load. So we're going to call ask user, and we're just going to type in an empty message because I want to use the default. That's fine. And quite frankly, I could probably just leave it empty and change my code to look for null, but at this juncture it doesn't matter. And then we're going to call game.start. and then we're going to call initiate responsive, which basically means now that we've started the game, start listening for responses from the end user as to do they want to stop it, etc. So let's go ahead and build this. So we'll do build project, and you'll see that it works with success. You can also right click there and do clean and build. And then let's go ahead and run this. We'll click debug, and you'll see here the first thing it does is it says choose the video game that you want to play. In my case, let's test our logic. So we want to make sure that if I type in a wrong selection, right, we want to make sure that it yells at me. So that's invalid. Uh-oh. Well, here's a great lesson, people. So notice I typed in 4323. Well, 4323 is not a valid selection, but we used .contains instead of .equals. So it still sees a 2 in that response. So in this case, the user did something wrong, but we didn't catch it because my code was too lazy. So we'll say ignore the case, but see if it equals. So equals ignore case. Great method. And this will make sure that if someone types in something, we're actually getting the exact output versus just looking to see if it exists in the string that was inputted by the user. So let's try that again. Debug. All right, so now if we do 2323, which 2 would normally have triggered it given our bad code, you can see now it says 1 or 2. 1 or 2, 5, no good. So we'll say 2. We know that's going to finish loading Sonic. And now it's essentially ready for my input. I could say stop, and it says Sonic has stopped, and then it says something custom, right? That was the line of code that we added just to the Sonic class. We can say pause, we can say start, we can say menu, and what if I type in just gibberish, right? Nothing. It does nothing because it's not a valid command. So you can see we've written a really basic application here. This application essentially has one interface video game, and you can see why using the interface has been extremely useful for us. You know, this method and this method, they don't have to know at all Sonic or Mario Brothers. All they know is that we get a video game, and we know what a video game is capable of doing. That's all we need to know. This is a great way, especially if you're an architect, to create interfaces that you then pass off to your developers to have to implement, so that all you're really worried about is this being architected properly? Are things going to be coded in a way where they make sense down the road, and they enforce the business logic that has to happen? A phrase that I hear often with interfaces is that an interface is a contract, and that is correct. So an interface, if you want to get technical, an interface is a programming contract in which if you implement it, aka you sign it, you are forced to abide by that contract. Just like in the real world, you are forced to implement what's in that contract. So that's why you'll hear that term being thrown around. So that is the basics of an interface. One other note, and that is in Java you can implement multiple interfaces. That is not the case for some languages. Just to give you yet another example here, let's do an interface. We'll say so we have video game, but it might also be that the video game is part of I don't know, a Sega game, right? So it's a video game, but it's also part of Sega. And Sega may have some, you know, I don't know, some interface that says get system name, which, you know, oops, that's going to print out the name of the system. So let's go to Sonic. In the case of Sonic, we'll do a comma and we'll say Sega game. And you'll notice we get this red mark because we haven't implemented get system name. So we'll say public string get system name. And one thing, I'm just being lazy here, guys. I'm just going to return it here. We'll say Sega. All right. Add the override. And let me see if I spelled that right. So Sega game. Oh, it's void. Sorry, we want to pass back a string. There you go. So in the case of Sonic, it happens to be a Sega game. And all Sega games must have get system name, etc. So you can see this class adheres to video game, but it also adheres to Sega game. You can have multiple implements on a class, and really this is something that we can go in further depth about later. There are times and places where you might have many implementations on a class. I don't want to get into why and how you would use that later in the later down in the application. I would say that I don't see it often. I do see it on large applications, but it's not insanely common, although there's definitely a time and a place for it. So I hope that was informative. If there are pieces to this video that you felt were confusing, please leave a comment. I'll be more than happy to respond back to you and see if I can help. I think that interfaces are something that are highly valuable but greatly underutilized, and certainly using them in your applications help them to be used properly and will help you to build much larger applications that make sense as you start to get further into creating code that's polymorphic. So thank you for listening, and look forward to your comments.